It wasn't supposed to happen. Every alarm was silent, every sensor flat. Then, in less than 60 seconds, the ground beneath Taal Volcano tore open. Ash shot 2 kilometers into the sky. Instruments failed. Scientists froze. It wasn't the eruption itself that scared them. It was what they didn't see coming. Because every model said one thing. Every reading said one thing. Every computer said one thing. Taal should have been sleeping. Yet here it was, wide awake. And the scary question hanging over every lab in the Philippines and every research center watching around the world was simple. If we can't predict this, what else are we blind to? Let me take you back to the beginning. Taal is a volcano in the Philippines. It sits in the middle of a lake. People live all around it. Fishermen work on the water. Tourists visit every day. Scientists watch it every minute. For years, Taal was one of the most watched volcanoes in the world. Dozens of sensors, gas detectors, earthquake meters. Nothing escaped detection, or so they thought. Every day, mountains of data came in. Temperature readings, pressure levels, gas amounts. The system worked perfectly until it didn't. Scientists felt safe. They had tools. They had computers. They had algorithms. They believed they could see everything. Inside the monitoring room, screens blinked green. Numbers scrolled by. Analysts sipped coffee and checked graphs. Everything looked normal. Everything felt normal. But normal was about to die because Taal wasn't sleeping. It was hiding. Deep underground, something was changing. Pressure was building. Magma was rising. The mountain was getting ready. But the sensors saw nothing. The computers saw nothing. The scientists saw nothing. A few small earthquakes happened. Some gas readings looked weird, but nothing alarming, just background noise. In science, silence often means stability, but sometimes it's the calm before disaster. The data was perfect, one scientist would later say. Too perfect? That should have been the warning, because nature doesn't do perfect. Nature does chaos, and chaos was coming. Think about this for a moment. We live in a world of sensors. Your phone knows where you are. Your watch knows your heartbeat. Satellites track storms before they form. We believe we can predict everything. We believe we're in control. But what happens when the data lies? What happens when technology goes silent right before catastrophe? That's what happened at Taal, and it terrified the scientific world. Because if sensors can't predict a volcano, something we've studied for centuries, what else can surprise us? What other disasters are hiding in plain sight? The story of Taal isn't just about one eruption. It's about trust. It's about confidence. It's about the moment when humans realize nature still holds the cards. On October 25th, 2025, that moment arrived. It started like any other day. The sun rose over the lake. Birds flew. Water lapped against shores. Fishermen prepared their boats. In the monitoring center, analysts logged in. They checked screens. They reviewed overnight data. Everything was quiet. Everything was stable. Everything was wrong. Because beneath their feet, beneath the calm water, beneath the peaceful morning, the planet was about to speak. And when it spoke, it would shatter years of scientific confidence in seconds. The clock was ticking. The mountain was waking. And nobody knew. Let me explain something important. Volcanoes don't usually surprise us anymore. We have tools, we have science, we have warning systems. When a volcano gets ready to erupt, it gives signs. The ground shakes, gas escapes, the mountain swells. Sensors catch these changes days or weeks early. That's how it's supposed to work. That's how it worked for decades. But Taal broke the rules. To understand why, you need to know how prediction works. Imagine the Earth as a sleeping giant. When it wakes up, it moves. Those movements create tiny earthquakes, hundreds of them. Scientists call these precursor signals. Sensors buried in the ground catch these signals. Computers analyze them. Patterns emerge. Warnings go out. That's the system. That's the safety net. But what if the giant wakes up without moving? What if the signals never come? That's what happened at Taal. October 24, 2025, the day before the eruption, Scientists reviewed data like always. They saw small tremors. Normal. They saw gas readings. Normal. They saw temperature changes. Normal. Nothing suggested danger. "We had no reason to raise the alarm," said Dr. Maria Santos from PHIVOLCS, the Philippine Institute of Volcanology. "Everything looked stable, but here's what they didn't know. Deep underground, in chambers their instruments couldn't reach, magma was moving. Not fast, not loud, just slowly rising. The pressure was building in a place their sensors couldn't see. It's like trying to hear a whisper in a loud room. The whisper is there, but you can't detect it." Taal's magma chamber sits very deep, deeper than most sensors can measure accurately, and the magma moved through rock so dense that it didn't create normal earthquake patterns. No shaking, no obvious signals, no warning. The technology failed because nature found its blind spot. Think about a smoke detector in your house. It works great for fires in your kitchen, but what if fire starts inside your walls? The detector might not catch it until too late. That's what happened here. The sensors worked perfectly, but they were looking in the wrong place. Early morning, October 25th, 3:47 a.m., a technician in the control room noticed something odd. A data spike, a brief flicker on screen. It vanished in seconds. Probably a system error, she thought. She reset the monitors. But it wasn't an error. It was Taal trying to speak. The technician logged the event. She made a note. She moved on. Nobody raised an alarm. Nobody called emergency services. Nobody evacuated anyone, because the data said everything was fine. Here's the cruel truth about disasters. They often announce themselves, but humans don't always listen. We trust our tools more than our instincts. We believe screens over gut feelings, and sometimes that trust kills. The hours ticked by. 4 a.m. quiet. 4:30 a.m. quiet. 5 a.m. quiet. The sun started to rise. Fishermen woke up. Tourists prepared for day trips. Life continued because nobody knew. Inside the monitoring room, screens still blinked green. Numbers still looked normal. Coffee still got poured. But beneath the surface, the final moments were counting down. Pressure was reaching critical levels. Magma was pushing through the last layers of rock. The volcano was seconds from breaking, and every sensor stayed silent. This is the nightmare scenario for scientists. The thing they fear most. Not the disaster itself, but the failure to see it coming. Because if you can't predict it, you can't prepare for it. If you can't prepare, you can't save people. All the technology in the world becomes worthless if it can't tell you when danger is near. 5:10 a.m. The first real signal arrived. A tremor. Small but sharp. Different from the background noise. An analyst noticed. She leaned forward. She checked the reading. Before she could report it, another tremor hit. Stronger this time. Then another. Then another. The screen lit up with warnings. But it was already too late. The data had finally arrived. But the disaster had arrived first. 3 minutes. That's all they had. 3 minutes between first warning and explosion. Not enough time to evacuate. Not enough time to alert everyone. Not enough time to prepare. Just enough time to realize they were blind. 5:14 a.m. The ground shook hard. Coffee cups fell. Papers scattered. Alarms started screaming. 5:15 a.m. Cameras flickered. Sensors spiked. Readings jumped off charts. 5:16 a.m. Taal exploded. The water in the lake started churning, rising. Steam burst from the surface. Then ash. Then fire. The crater opened like a wound. Ash shot into the sky, 2,000 meters up, a black column rising in seconds. The shockwave hit nearby towns. Windows rattled. Dogs barked. People ran outside. On the monitoring screens, everything went black. Sensors failed. Cameras cut out. Data streams stopped. Every instrument went blind at the exact moment they needed it most. "We lost everything," said one technician later. "The system just died." In the monitoring room, panic set in. Scientists grabbed phones. They called emergency services. They tried to restart systems. Nothing worked. Outside, the eruption continued. Fishermen on the lake saw the water rise. They felt the heat. They heard the roar. It was like the lake was breathing fire, one survivor said. We turned our boats and raced for shore. Ash fell like snow, but hot, burning. The sky turned dark even though the sun was rising. In towns around the volcano, people grabbed their children. They ran. They didn't know where to go. They just knew they had to move. No sirens had warned them. No alert system had activated. They were on their own. This is what happens when prediction fails. Chaos, confusion, fear. Dr. Antonio Reyes stood in the monitoring center watching his screens fail. He's studied volcanoes for 30 years. He'd never seen this. This wasn't in any of our models, he said quietly. We had no precursor signals. Nothing. Around him, his team worked frantically, trying to restore systems, trying to understand what happened, trying to help people they couldn't reach. The eruption lasted only minutes, but those minutes felt like hours. Ash covered everything: cars, houses, fields, a grey blanket of destruction. The death toll was low. Only 3 people died, but hundreds were injured. Thousands lost homes. The volcano had been merciful, but science felt crushed because the technology failed, the prediction system failed, the confidence failed, and that failure hurt worse than the volcano itself. Think about what this means. We spend billions on sensors. We launch satellites. We build computer models. We hire scientists, all to predict disasters, all to save lives, all to feel safe. But Taal showed us something terrifying. Nature can still surprise us, no matter how many tools we have, no matter how much data we collect. Nature holds secrets we can't see. The volcano had been silent because pressure was building in layers their instruments couldn't reach. It's like trying to predict a storm by watching the ground. You're looking in the wrong place. The sensors measured what they could measure, but what matters was deeper, hidden, invisible. And when it finally showed itself, it was too late. This is the scientist's nightmare, the question that keeps them awake. What if we're always looking in the wrong place? What if the next disaster is building right now, and our sensors can't see it? What if technology gives us false confidence instead of real safety? After the ash settled, after the eruption stopped, scientists began the hard work. They collected data. They reviewed recordings. They checked every sensor. They needed to understand what happened. More importantly, they needed to understand what they missed. The answer they found was both simple and terrifying. They hadn't missed anything. The signs simply weren't there. Or rather, the signs were there, but in a form their technology couldn't detect. Magnetic interference from deep magma chambers, pressure changes in rock too dense to measure, chemical reactions that didn't release detectable gases. Taal had erupted using a pathway science hadn't fully mapped yet. It wasn't human error, Dr. Reyes explained later. It was human assumption. We assumed if something major was happening, we'd detect it. We were wrong. Around the world, other scientists paid attention, because Taal isn't alone. There are hundreds of active volcanoes. Millions of people live near them, and they all depend on the same prediction systems. If those systems have blind spots, everyone is at risk. The eruption sent shockwaves through the scientific community. Not physical shockwaves, psychological ones. It shattered confidence, it raised questions, it forced humility, and it left one question burning in everyone's mind. If we can't predict this, what else are we blind to? The days after the eruption were quiet, but the silence felt different now. Scientists sat in labs replaying data, over and over, looking for what they missed. Timestamps were checked, files were reviewed. Every sensor reading was analysed again. The pattern was clear, or rather, the lack of pattern was clear. Every reading matched normal levels right up until the eruption. Then chaos. Then nothing. There was no gradual build-up, no warning curve, just stable, stable, stable explosion. It's like watching someone's heart monitor, one researcher said. Normal beats, then flatline. No warning, no transition. But hearts don't work like that, and neither should volcanoes. Yet Taal did. The scientific papers started coming out. Conferences were called. Experts gathered to understand what this meant. The conclusion was uncomfortable. Volcanic prediction systems work at most of the time, but not all the time, and the exceptions are impossible to predict themselves. You can't predict when prediction will fail. That's the cruel irony. Dr. Reyes stood before a room of colleagues. His presentation was simple. "We thought we understood Taal," he said. "We thought we knew its patterns, but we were measuring the surface. The real action was happening deeper than we could see." He showed slides, diagrams of magma chambers, sensor placement maps, data graphs. "Our sensors are like microphones held above water," he explained. "They catch sounds at the surface. But if the real noise is deep underwater, we hear nothing." The room was silent. Everyone understood. Technology has limits, and those limits can cost lives. But here's what hurt most. This wasn't the first time, and it wouldn't be the last. In Alaska, earthquakes had struck with minimal warning. In Italy, Mount Etna had flared up unexpectedly. In Indonesia, tremors surprised scientists. A pattern was emerging, not a pattern of eruptions, a pattern of failed predictions. Nature was finding the blind spots, over and over. "We're not learning fast enough," said Dr. Chen from the Global Volcano Monitoring Network. "Every surprise teaches us something, but there are too many surprises." The human cost at Taal was relatively small, 3 deaths. A miracle, really, but it could have been thousands. On a different day, at a different time, with more people nearby. Luck saved lives, not science. That reality stung. Families who lost homes gathered in evacuation centres. They had no warning, no time to grab belongings, no chance to prepare. "We trusted the scientists," one woman said. "They always told us before. This time, nothing. We just heard the explosion." There was no anger in her voice, just confusion, sadness. Because how do you blame scientists for not seeing something invisible? How do you blame technology for having limits? You can't. But that doesn't make the loss hurt less. Insurance companies reviewed their policies. Governments examined their warning systems. Engineers proposed new sensor designs. But everyone knew the truth. You can improve. You can add sensors. You can build better models. But you can't eliminate the blind spots completely. Because the Earth is too big, too deep, too complex. We're trying to predict a planet using tools that measure tiny fractions of it. It's like trying to understand an ocean by testing a cup of water. The information you get is real, but incomplete. And incomplete information creates false confidence. That's the real lesson of Taal. Not that technology is useless, but that technology has limits. And we must remember those limits. We must stay humble. We must prepare for surprises. We must accept that nature will always have the final word. 1 month after the eruption, schools reopened, businesses rebuilt, life continued. The volcano sat quiet again. The lake looked peaceful. Tourists started returning. But the scientists stayed nervous. Because quiet doesn't mean safe anymore. Quiet might just mean hidden. Dr. Reyes visits the monitoring station every day now. He checks the screens, reviews the data, watches for patterns. But he also does something new. He looks out the window at the volcano itself, without sensors, without computers, just looking, just watching. Data is important, he says, but so is instinct, so is respect. The mountain will do what it wants. Our job isn't to control it. Our job is to be ready when we can be, and humble when we can't. That's the shift, from confidence to humility, from control to preparation, from prediction to respect. Science didn't fail at Taal, science learned, but the lesson came with ash and fear and loss. Some lessons still come with fire. The question now is whether we remember, whether we stay humble, whether we respect the limits of our knowledge, because the next Taal is out there, somewhere, building pressure, staying quiet, and we might not see it coming either. A volcano is sleeping right now, somewhere in the world, maybe in the Philippines, maybe in Indonesia, maybe in Italy or Japan or Alaska. Its sensors read normal, its data looks stable. Scientists feel comfortable, but deep underground, something might be changing, something invisible, something we can't measure yet. That volcano might erupt tomorrow, or next year, or never. We don't know, and that's okay, because the story of Taal taught us something important. We don't have to know everything, we just have to respect everything. For years, humans believed we could conquer nature with technology. We built sensors and satellites. We created models and algorithms. We convinced ourselves we were in control. Taal reminded us we're not. We're observers. We're students. We're guests on a planet that's been here billions of years longer than us. The Earth doesn't owe us warnings. It doesn't owe us time. It simply exists. And we must learn to exist with it. That means better sensors, yes. Better models, yes. Better warning systems, yes. But it also means something more important. It means communities that prepare even without warnings. Evacuation plans that work in minutes. Buildings that resist ash and earthquakes. People who know what to do when the ground shakes. Because technology will fail again. Predictions will miss again. Nature will surprise us again. That's not pessimism. That's reality. And reality requires respect. The scientists at PHIVOLCS work every day to improve their systems. They're adding deeper sensors. They're studying new types of signals. They're building better models. But they're also teaching something else. Humility. We can't promise we'll see everything, Dr. Reyes tells communities now. But we promise we'll never stop trying. And we promise we'll tell you the truth about what we can and can't do. That honesty matters. Because false confidence kills. Real preparation saves lives. The people living around Taal are rebuilding, but they're also preparing. They practice evacuation drills. They keep emergency supplies ready. They watch the volcano themselves, not with fear, with respect. That's the legacy of October 25th, 2025. Not the eruption itself, but the lesson it taught. Nature is powerful, technology is limited, and humans survive best when they remember both. The next time you check the weather on your phone, remember something. The forecast might be wrong. The sensors might miss something. The data might have blind spots. And that's okay, because now you know. You're prepared. You respect the limits. The next Taal is coming. We don't know when. We don't know where. But we'll be watching. We'll be ready. We'll be humble. Because science in shock becomes science in wisdom. And wisdom keeps us alive.